Welcome to the chapter 6.2 lesson video where we talk about solving trig equations from 0 to 360 degrees. Now, this is a bit different than the 6.1 lesson video. The 6.1 lesson video was all about what the calculator will tell you. It'll tell you what the answer is when you plug in inverse sine, inverse cosine, those type of things. This is about solving equations for all possible solutions within one rotation from 0 to 360. So that's the idea here. There's going to be multiple solutions on a lot of problems, not every problem, but on a lot of problems there's going to be multiple solutions. And so we have to be aware of that this is a different type of problem. And the way you're going to know it's a different type of problem is going to say something about all solutions from 0 to 360. When it doesn't say that, that's when there's only the one in the limited bit that we did in 6.1. So let's go ahead and get started. So we're going to talk about how we can solve trig equations linearly for all possible values from 0 to 360. We're also going to talk about some more complex ones as well. This is going to involve things like factoring, square rooting, and quadratic formula to use those methods in order to solve and get all the solutions from 0 to 360. All right, so let's just go ahead. We'll do a simple one here. I'm going to read these directions over here on the right for you. Using our inverse trig function and algebra skills, we can solve here. So we're going to start by getting the trig function alone on one side. So a lot of times there's going to be other stuff over with the trig function. We're going to algebraically divide, add, subtract, multiply to get it alone. All right, draw the possible angles, whether they're positive or negative. So we're then going to draw quadrants, and we're going to draw all the possible angles from 0 to 360. A lot of times there's going to be two solutions, but sometimes there might be one, and you just kind of have to reason through what your possibilities are here. All right, and then you're going to determine what angles, based on those inverse trig functions, make that happen. Often there are multiple solutions because now we're looking for all theta from 0 to 360, not just the limited ones that we talked about before. All right, so let's go ahead and try it with this problem right here. So the first thing we're going to do is divide both sides by 2. So we get the sine of theta equals -1 over 2. All right, so now sine of theta is by itself, so we're going to go ahead and draw a quadrant, and this is how you show your work every time. So we have sine of theta is -1/2. Well, sine is negative in these two quadrants, quadrant 3 and quadrant 4. Sine is my opposite side over my hypotenuse, my opposite side over my hypotenuse. All right, so with that information, we can kind of think about this. We can say, all right, well, what triangle do we know has an opposite side of 1 and a hypotenuse of 2? Well, that would be a 30, 60, 90, and the 30 is across from the 1. So we know that these are 30-degree reference angles. If it helps, you can write that in there, 30-degree reference angles. And so what angles would those be from 0 to 360? Well, 180 plus 30, that gives us one answer of 180 plus 30 is 210. And it gives us another answer of 360, so that was this angle over here. And then gives us another answer of 360 minus 30 of 330. So these are the two possible values that make this occur. All right, so 210 and 330 are my thetas that make this equation true. These are my solutions for this problem. And notice I wrote it in this with this like kind of brackety notation. So theta is everything inside those braces there. All right, let's try some more. All right, so this one on the left, we have cosine of theta equals √3 over 4. I'm going to go ahead, I'm going to multiply by 2 on both sides. So I'll go ahead and multiply by 2 on both sides. So that will give me the cosine of theta equals 2 √3 over 4. And I'll simplify that down to be cosine of theta equals √3 over 2. All right, I'll then draw my angles. Cosine, that's a positive √3 over 2. Cosine is positive in quadrants 1 and 4. Cosine is adjacent over hypotenuse. That means this is √3, hypotenuse is 2. And so that means my opposite side would be 1 and -1. So what kind of triangle is this? This is a 30, 60, 90 triangle with a 30-degree reference angle. So in quadrant 1, a 30-degree reference angle is 30. And in quadrant 4, it is 330. So my two solutions here, theta equals 30 and 330 degrees to make this equation true. So that's what the solution is. All right, so that's our first example there. All right, now for our second example. So our second example got covered up a little bit. And I'm actually going to go ahead and move this answer out of the way. So I will move that down here. So theta equals 30 and 330, just to get out of the way of the next problem. All right, so the next problem, we're solving for tangent, get tangent by itself. So we'll go ahead and make that into tangent of theta, and we're going to subtract the 5 from both sides, so we get tangent of theta equals 0. All right, so then we got to ask ourselves, when does tangent equal 0? All right, so tangent is my y over my x value. All right, so tangent is y over x. So when is my y value 0? It's when it hasn't gone up or down at all. So that's these two spots right here. That's where y is 0. So 1 comma 0 and negative 1 comma 0. That's where y is 0. So that is my tangent of theta. And so that is pretty easy to identify what those angles are. So those two angles are at 0 and 180 degrees. Right, so that's my solution here is 0 and 180 degrees. All right, and then our next example, we're going to go ahead and divide by 2 on both sides. So we'll divide by 2 on both sides, so that's going to give us secant of theta equals negative 1/2. Now, you might start trying to draw stuff and be like, well, secant is negative when cosine is negative, so that's quadrants 2 and 3. But wait a second. Secant can only be bigger than positive 1 or smaller than negative 1. So secant can't actually equal negative 1/2. So if that happens, if it is something that doesn't exist, or if it says like sine equals 5, which can't happen either, then you just say your solution is undefined. So you can either use this symbol, or you can say theta equals and then leave it empty to say that there's nothing there. Either of these are acceptable answers here. All right, so this is just a couple examples. We will do some more in class as well. All right, now there's some more complicated things we got to keep in mind. There's always more complicated problems, and so we'll talk about some of them here as well. These are some more challenging situations that might occur. All right, so let's read through some of these tips right here. There's some other information on here as well that you can look at. So the first one says, decide if the equation is linear or quadratic. Those first 3 we did, those were all linear, so they were quite easy to solve. Other ones might be quadratic and need to be factored or square rooted or quadratic formulaed, and those are things you can keep in mind. If one trig function is present, solve with algebra and factoring. So those first 3, they were all just one involved. Some of them might have multiple trig functions, in which case you need to do something else to it. Try and arrange it so that one side is equal to 0 and then factor. If it's this big long thing, try and make it equal to 0 and then factor. That's going to make your life a little bit easier. If it's not factorable, you can always try the quadratic formula, which you should be familiar with. And then try and use trig identities to change the equation. Now, trig identities is a thing that can come up. I don't think we'll do any in the video, but we might see one of those on the assignment in class. We will always look for all possible answers between 0 and 2 pi or 0 and 360. I don't care. You can use radians or degrees. I will most likely use degrees for most of this, but I know radians are acceptable as well. This means we'll often have 2 answers that are in different quadrants. All right, so let's go ahead. I got, I think, 4 more examples. They're a little more complicated, so let's go ahead and tackle them. If you haven't taken a break at this point, pause the video, take a break for a few minutes, and then come back. All right, so each of these 2 problems are going to involve factoring and then solving. All right, so this first one here, this one on the left, first thing we're going to do is we're going to make one side equal to 0. So we're going to add that cosine over. So cosine theta, cotangent theta, plus cosine theta equals 0. All right, now what we see, since we have everything on the same side, is they both have a cosine, so we can factor that out. So we get cosine theta equals, cosine theta and then parentheses, cotangent theta plus 1. All I did there was I pulled the cosine out of this one, it left me with cotangent. I pulled the cosine out of this one, it left me with a 1. Well, both of these things are equal to 0 is what we're saying here. So we can separate them apart. We want to know, when does cosine of theta equal 0? And when does cotangent of theta plus 1 equal 0? Well, we can move that 1 over, and we can change this to be cotangent of theta equals negative 1. So when do these 2 things occur? Well, we're going to draw our angles to find out. Okay, so cosine is r or x over r. So when is our x value going to be 0? It's when we haven't moved left and right. So that's up here at 90 and down here at 270. Those are the points 0, 1, and 0, -1. Okay, so those are my two places where cosine is going to be 0. And then cotangent is going to be negative in quadrants 2 and quadrants 4. All right, and cotangent is my adjacent over my opposite. So this is -1 and this is 1, and this is -1 and this is 1. So cotangent is in those triangles, and those are 45-degree reference angle triangles. So if we're identifying all these angles at which they occur, we said this is 90, we said this is 270, we said this is 45 degrees, take away from 180 is 135 degrees. And this one is 45 from 360, which is 315 degrees. So last thing we have to do is write all of our answers. So there's lots going on here. So we have 4 answers this time. So we write our braces and we go 90. I like to list them in order. 135, 270, 315. That's numerical order is what I mean. Right? And so we got all 4 possible answers that'll make this equation true between the values of 0 and 360. So all our answers are between 0 and 360, and we include 0. So if it's between 0 and 360, you pick 0, not 360. All right, so that's one type of factoring, the greatest common factor. The other type of factoring would be a diamond problem factoring. So you'll see this on the other example here. You have sine squared 2 sine plus 1. Well, we practiced this last chapter, so we're just going to go ahead and factor this. We're going to say what multiplies to 1 and adds to 2. Well, that's 1 and 1. So that means we can factor this to be sine of x plus 1 times sine of x plus 1 equals 0. Well, we have the same thing twice, so we really only have to solve one part here. Sine of x plus 1 equals 0, which we can change to be sine of x equals -1. So when does sine equal -1? Well, sine is my y over my r value, and that's only going to be -1 at one spot. That's going to be -1 down here when my y value is -1 and my r value is also 1. All right, so well, that one spot down there is 270. So it doesn't always have multiple solutions. In this case, our x value has just one solution. X equals 270 degrees. I'm only using x because that's what it was used in the original problem. If it's theta, use theta. If it's x, use x. All right, so that's factoring. So those are 2 different examples of factoring problems. Let's move on and try something else. All right, so one other thing we can do is take the square root, but you have to remember, anytime you take the square root of both sides, you have to include a plus or minus. So we go sine x equals plus or minus the square root of 1. Well, the square root of 1, that's pretty easy. So this is the sine of x equals plus or minus 1. Well, that breaks us into 2 different scenarios. When does the sine of x equal 1, and when does the sine of x equal -1? Well, we draw our pictures. Some of you may know this off the top of your head, but sine of x will be 1 up here at 90. So that's it, and it's at 0, 1, r equals 1. And sine will be -1 down here at 270. 0, -1, and r value is also 1. Now, I have these memorized. I've done this enough times, so I really know what these are. But we can think about this. We can figure out when does sine equal 1, when does sine equal -1. That's something we should be able to figure out. Well, so we have 2 angles here. Our first solution up here gives us 90. Our second one gives us 270. So these are both our valid solutions. So in this case, x equals 90 and 270 degrees. All right, so that's another type of problem, is a square root. And what that causes is that causes this plus or minus thing, which causes us to split and do 2 separate graphs for 2 separate problems. But they all go into the same answer box down here at the bottom. All right, and we got one last example. Our last example is probably the most beautiful because we have to do the quadratic formula, which everyone loves. In case you forgot it, your quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all divided by 2a. That's our quadratic formula. Here our a is 1, our b is 2, and our C is -1. This is going to be a little bit messier, and it is going to require a calculator. So make sure you have a calculator out. Make sure your calculator is in degrees mode, and we'll go ahead and figure this out here. So A is 1, B is 2, C is -1. So we go x equals -2 plus or minus the square root of 2 squared minus 4 times 1 times -1 all over 2 times 1. All right, and this is not x, sorry, this is the cosine of x equals that. So we just use whatever this is. It wasn't x this time, it was cosine x. So we'll go ahead and simplify that down. So we get -2 plus or minus the square root. Let's go ahead and do the math here. This is 4 minus 4 times 1 times 4 plus 4 is 8. So that's -2 plus or minus 8 all over 2. Cosine x equals -2 plus or minus 8 all over 2. And yeah, so at this point, what we can do is we can go ahead and we can plug this into the calculator, because at this point we don't need to be too exact. So we'll go -2 plus the square root of 8 and divide by 2, and we get the two answers. The first answer we get is 0.4. We'll go a couple decimal places, 414. And then we'll do the same calculation, -2 minus 8, and then divide by 2, and we get -2.414. Now, we immediately run into an issue with one of these. This is saying cosine of some angle equals 0.414 and -2.414. Well, one of those is impossible. -2.414 is not between 1 and -1, so that one gets eliminated right away. We can't do anything with that one, so it's a useless solution. So we only have one solution here, only one that we worry about. Cosine of x equals 0.414. Well, we're going to go ahead and use our calculator. So if we plug in our calculator, make sure it's in degrees mode. You do the inverse cosine of 0.414. Press enter, you get 65.54. So if you do the inverse cosine on both sides right here, inverse cosine, it's going to tell you that x equals 65.54 degrees. Well, that's great and all, but what does that actually mean? Well, what that means for us is that means that that's potentially one of our solutions. All right, well, we know cosine is going to be positive in these two locations. Okay, in these two locations, cosine is going to be positive. Well, that 65.54 is this angle right here, 65.54. But that's the reference angle for the other angle here as well. So our first angle was the 65.54, and the other angle is going to be 65.54 behind 360. So we do 360 minus that number, 65.54, and we get that this other angle here is 294.46. Right, so it's the same reference angle, right? They're the same angle, the same distance. That's what makes them the same value, is they're the same reference angle. This little angle on the inside is the same. But the first one gave us our quadrant 1, and the other one gives us our other place where cosine is a positive value. All right, so we just have to write our final answers. So we say x equals 65.54 and 294.46. All right. Well, that's our last example, and that is a little bit trickier of one. If you have any questions, please reach out to me. We'll go over some of each of these in class, and hopefully it helps it make a little more sense. Otherwise, I'll see you in our next live session, and I hope you have a great day.